Silicon Valley is pushing AI tutors to optimize your child's brain, while psychologists make an urgent case to get them outside into nature. This creates a direct friction for parents, the desire to prepare children for a hyper-digital future without sacrificing their physical or emotional health. Most parents feel a sense of guilt, believing they must choose between technological optimization and a natural childhood. To understand the trade-offs, we look at these two dominant learning environments side by side. The AI industry markets frictionless skill acquisition. These tools offer instant feedback, adaptive pacing, and total availability. Advocates for outdoor learning focus on physical engagement. They emphasize sensory immersion, improvements in health, and organic problem-solving within an unpredictable environment. However, evaluating these two as direct competitors is a category error. They are designed to solve entirely different cognitive problems. We will conduct a strict, objective evaluation of the return on investment for both environments. We will look at the evidence for each and then detail the hybrid protocol, a powerful way to integrate both tools to maximize learning while actively protecting your child's data and overall development. Dropping the tech versus nature binary is the necessary starting point for optimizing a child's developmental environment. We can map these developmental zones using a radar chart, looking at academic precision, sensory engagement, health, availability, and social skills. The input for an AI tutor involves deploying software for targeted homework practice and repetitive learning. The outcomes create a sharp, specialized profile. It hits the maximum for academic precision and availability, but remains at 0 for everything else. For a time-poor parent, this tool buys back supervision hours while ensuring a child makes rapid progress in their schoolwork. The primary trade-off is over-reliance. A child may learn to bypass critical thinking entirely, using the AI to simply fetch answers rather than understanding the logic behind them. There are also structural risks. Commercial platforms collect significant data, making child-safe models a requirement for privacy. Reliability is another factor. AI can hallucinate, making mathematical or factual errors that can mislead a student if they aren't double-checking the work. Critically, these systems lack empathy. They cannot read a child's physical frustration or detect when they are losing focus. Without an adult to monitor the session and catch those emotional cues, the efficiency of the software can lead to rapid disengagement. AI is an unmatched tool for academic repetition, but it is blind to the physical and emotional context required for growth. Now consider the outdoors. The inputs for nature play are unstructured and multisensory, such as building structures with sticks or taking sensory walks. When we map nature play, the profile is the exact opposite of the AI. It spikes on sensory engagement, health, and social skills. As you can see, the two shapes have 0 overlap. The biological outcomes are specific. Sunlight provides the vitamin D necessary for bone health, and navigating uneven terrain builds gross motor coordination that a screen cannot simulate. Group nature activities also improve collaborative problem-solving and significantly reduce student stress levels. For parents focused on optimization, the trade-off is that this progress is messy. You won't find easily measurable academic metrics in the forest. Logistically, nature play requires a high input of adult supervision and safety monitoring. There are also geographic limits. Access to safe green spaces is unequal, and outdoor learning is often restricted by the weather. Most importantly, nature cannot provide the targeted, sequential instruction required to master a standardized digital curriculum. Because outdoor play doesn't include interaction with logical digital systems, a child who never leaves the forest floor will miss the technical training required for modern computer literacy. The radar chart confirms that these environments occupy different zones. One provides the academic structure the other lacks, making them functional partners rather than rivals. The optimal strategy for the modern world is a conscious hybrid approach that uses both environments as specialized tools. This hybrid protocol starts by identifying your learning objective. It then splits into 2 paths: repetitive skill mastery and emotional regulation. For repetitive drills, like math formulas or grammar, use the AI tool for maximum efficiency. To fix the digital-only gap, immediately follow that session with an outdoor activity that grounds the concept. If they just did a geometry lesson, have them find symmetrical patterns in the leaves. For exploration and emotional health, prioritize unstructured nature play as the primary engine. To fix the nature-only gap, Introduce a child-safe AI to help the child research the insects or weather patterns they discovered outside, building their digital literacy through real-world curiosity. Both pathways lead to the same final requirement: active parental involvement to synthesize these experiences. Select the tool based on the specific developmental milestone your child is facing today. Use frictionless AI to close academic gaps, and use friction-heavy nature to build a resilient human being. By orchestrating both digital learning and natural discovery, you prepare a child to think critically and solve problems in both the digital future and the physical world.